Alright, yesterday you were supposed to try to do the 95% confidence interval for slope for this problem with average monthly temperature and electrical usage. Alright, so we're going to make sure you know how to do that. So I'm going to write it all up here instead of down there so I don't just scroll back and forth.
Okay.
First of all, we're doing a T interval for slope. So that's important that you know what that's called. Second, if you're doing an interval, you're supposed to check the conditions. So your 4 conditions are, is it linear? And how do you know? Scatter plot of temperature versus electrical usage is, or has a linear form. And so that's their scatter plot. The residuals plot is showing no pattern. So that's how you answer if it's linear. 2, independence. Can we assume that each month, since we're doing average temperature, that each month is independent of the next? We're going to. The third condition is normality. So you have a residuals histogram. They take all the residuals and put them into a histogram. So is your histogram approximately normal? So histogram of the residuals is roughly unimodal and symmetric. And then the last thing, going back to the residual plot, we want to make sure that the residuals are equally scattered about the horizontal axis. So the residuals are equally spread around the horizontal axis. Questions about the conditions? They gave you all those photos. Either they're going to give you all the graphs or they're going to say assuming the conditions are met. Most of the time they tell you just the conditions are met. But if you're given all the graphs, you should be able to check them. All right, so if we're going to actually do the confidence interval, remember your confidence interval in this case is slope plus or minus, you're still doing a T interval, with this time n minus 2 degrees of freedom, times the standard deviation or standard error of the slope. So what values should I put there? Excellent. Amazing. Thank you very much. Everyone know where those values came from? It's inverse T. You have a 95% confidence, so your area is 0.025, and then there were 12 months, so 12 minus 2 is 10 degrees of freedom. Other questions about where the numbers came from? Again, we're just looking at slope, so you just need the coefficient and the standard error of the coefficient for the variable. Okay, so then if you go ahead and calculate that, someone want to tell me what it is so I have to calculate it, since you guys did it for homework? Negative 39 point, what'd you say? Awesome. All right. Questions about how I'd have gotten an interval if you had the actual setup? Once you have an interval, you write the conclusion. In your conclusion, you're talking about slope. So let's talk about slope before we write the conclusion. So here's your slope. Just in general, if we are said to interpret the slope, we did that yesterday, we reviewed all that stuff. So not thinking of the confidence interval, just in general, interpreting the slope. What would I say about slope? Well, I said interpret the slope in context. What do you write? Increase in average temperature. Kilowatt hours. Decrease. Right. So for every 1 degree increase in average temperature, your electrical usage decreases by 50.9 kilowatt hours. That's what slope is, right? So if you're interpreting the confidence interval for slope, you're using that exact same idea. So your confidence interval conclusion should be, I am 95% confident. That for every 1 degree increase in average temperature, there will be a decrease in electrical usage of 39.8 to 62 kilowatt hours. That's your interpretation for the confidence interval. You interpret the slope within your interval. Again, the whole point is we're trying to capture, we have a sample, and we have a slope for our sample. We're trying to capture what the quote-unquote true slope would be if we had all of the average temperatures for all the months forever. All right, so questions. All right, and today we're going to go and do hypothesis tests, and then we're going to go back and we'll look at, you'll have some more intervals and some more hypothesis tests to look at. So we're going to note that down. All right, so we looked at the front part of this yesterday. We did confidence intervals. So on the back of the front page, we're going to talk about hypothesis tests. So if you do a hypothesis test, in this case we're doing a t-test for slope, just like we did a t-interval for slope, we're doing a t-test for slope. So if you're going to do a hypothesis test, there's 4 steps. You state your hypotheses, you check your conditions, you do the mechanics, you write a conclusion. Again, all of these on the AP exam are going to be based off of computer output. So you have to know what the hypotheses are supposed to be, so you can write them. You know what the conditions are. Hopefully they'll say assume they're met, so you have to check them. The mechanics, you don't have to do by hand because they're in the computer output. And then you make a conclusion like you always do about the p-value. So this should not be that difficult. Okay? So, here we go. We're talking about slope. Now, again, if you're thinking about everything we've done in a hypothesis test before, your null hypothesis always has a parameter in it. So, for example, when we did proportions, you had p equals something, but your sample was p hat. When you did means, we had mu in our null hypothesis, even though we were using x bar, right? Same thing here. Slope is capital beta sub 1. That's slope. All right. Lowercase beta, so little b sub 1 is our sample. Okay. So your null hypothesis, for all intents and purposes, and I would say all the time in this class, should be that the slope is 0. We assume that there is no relationship between the variables. Right? The slope of 0 means we have a straight line, means it's just like random scatter. Right? So we're assuming there is no relationship between the variables, no association. So if you want to write that in words, you can. Okay? But we're assuming there's no association. For the alternative, this is very important. Again, you're basing this off of a computer output. For the computer outputs always set up the test so the alternative is not equal to 0. Right? They're calculating the p-value for you in the computer output. So the computer is doing the test assuming that the alternative is not equal to. Now, your test that you're doing might be that you want to see an increase or decrease. You want to see greater than or less than 0. In which case, you need to look at the p-value and make some adjustments. When we're going to do an example of that in a second. But know that the computer output did it based on the fact that they're saying it's equal to 0 and then not equal to 0. Just keep that in mind. Okay? We're going to do an example where it's different. But just know that's what's happening in the computer output. The conditions are the same as the conditions from yesterday. Is it linear? Are your data values independent? Are your residuals approximately normal? Are the residuals equally spread about the horizontal axis? So same thing. Then we're going to do the mechanics. In the computer output, you can see where it says T and P. It'll be somewhere in the computer output. T is your T statistic, and P is your p-value. Again, we're only doing tests about slope. Slope is always with the variable, so you wouldn't even need to look at the constant line. You would only look at these two numbers. Okay? So don't get it twisted and think that there's like a million numbers you're supposed to look at. So there's the mechanics. You're going to write down T, p-value, and it would be nice to write down the degrees of freedom. But you don't have to do anything. You're just writing them down from a table. Then you make a conclusion. All right? Is your p-value high or low? Do you reject or do you fail to reject? Is there evidence that the variables are associated or not? Depends on what you said at the end. All right? So same scenario we've been seeing over and over and over again. So with that being said, we're going to go through this question on the next page. So I'm not going to split back and forth. We're using this computer output right here, the one at the bottom of the page with the bubbles. But I'm not going to flip back and forth. You have it in your packet. I have it sitting right next to me. So that way we don't have to go back and forth 20 times. Okay? Okay. That's up to you. All right, so A is not about a test or an interval. It just says, find the equation of the least squares regression line. That just means write the equation. If you remember the scenario, it was talking about Amber, and she selected a sample of students to report their number of hours spent studying for their final exam and their score on the final exam. Right? That's what this is about. So if I was going to write the equation, how would I do that? I'm just writing the prediction equation. It would be something hat. So again, we're basing this, it was how many hours you studied, how it reflected on your final exam score. So what is hat? Final exam score. We're trying to predict final exam score from study hours. Okay. Yes, study hours is your variable in the table. So that's your x. Okay. So continuing on the equation, what do we have next? Just writing the equation. So what comes next? $62.328. 62.328 is the y-intercept. On the table, it says constant coefficient. That's your y-intercept. Just like yesterday in the calculator. Okay, what comes next? Exactly. You have your slope times your x in the table. X is study hours. The coefficient or next to it is the slope. Did some of these yesterday when we did that review. So make sure you know what you're doing there. It says to be sure to define the variables in the equation. So if you just use y hat and x, you would need to say x is study hours, y is final exam score. Or you could just do it like I taught you to do it with the variables as the words, and then you wouldn't have to worry about it because it's already there. Okay? All right. B says interpret the slope and y-intercept in the equation. So that means write sentences about what they mean. So let's do slope first. If I'm interpreting 2.697 in context, what does that mean? Mm-hmm. Increases 2.67 points. Perfect. Right, for every 1x, y increases or decreases by whatever the slope is. Okay, y-intercept is always where x equals what? 0. So what does that sentence sound like? For 0 study hours, we predict or we expect a final exam score of 62.34 or 33, I guess, whatever, points. Yeah? C, what percent of the variation in students' grades can be attributed to a linear relationship to the number of hours spent studying? It would be the r squared. Right? That's just like the sentence we normally write. It's just in question form. Normally it asks you to interpret r squared in context, and you have to write the sentence. Here they asked you the question to catch you off guard. The sentence that they said to interpret r squared in context would be 56.7% of the variation in students' final exam score is accounted for by the number of hours spent studying or by the linear model. So it just gives you the statement in question form. You got to figure out that's the percentage. It gives it to you in the computer output. Computer outputs give you two things sometimes because they get longer and more complicated, so try to filter through and find what you need. If they give you an r squared and an r squared adjusted, have we ever talked about r squared adjusted? No, so you ignore it. All right, D we did yesterday together, so I'm not going to go over it again. Most people wrote it on the front page over here. It's the one I did. Okay. So E, though, is to do a hypothesis test. So we're going to do the hypothesis test together. Is there evidence at the 0.05 level to suggest that student scores increase with the number of hours spent studying? First of all, again, every time you see is there evidence, that is code for do a hypothesis test. The 0.05 level, what is that? That's your alpha. That's what you're going to reject or fail to reject by. And again, notice it says to suggest that student scores increase. Okay? So if we're doing a hypothesis test, the first thing we should do is write some hypotheses. Our null is that there is no relationship. Our alternative is that there's a positive relationship. Right? That's what I should write based on the question. But remember what I said earlier? That's not what the computer output did, so we're going to have to be careful. Okay? It's not that big of a deal, but just keep that in mind. In the actual prompt on the previous page, it says assume all the conditions have been met. Okay, so we don't have to check any conditions. So the conditions have been met, so we can do a t-test for slope. You need 3 numbers. T, the p-value, and it would be nice to write down the degrees of freedom. There were 12 students sampled. So what are the degrees of freedom? 10, because it's n minus 2. In the table, you should be able to find t and p-value. Again, this is for the slope, so you need to look at the line that says study hours, because that's the line that talks about the slope. So what is t and what is p? We're going to talk about that in a second. What's t? 3.62. For argument's sake, just because I can, let's say they didn't give you the p-value in the table. They gave you t, though, and you have the degrees of freedom. You should be able to then find the p-value. How can I find the p-value if I have t and I have the degrees of freedom? T CDF. Right, we go from 3.62 to infinity because we're looking for an increase. We type in, we could do that. Most of the time they're just going to give it all to you, but just for argument's sake, you could do that. All right. Now, the p-value isn't really 0.005. That's what happens for the test that's two-sided, where the null alternative is not equal to. All right? So that's a two-sided test. Remember, you have not equal to, you always multiply the p-value at the end by 2. Our test is for an increase, so I need to divide the p-value by 2 to get the p-value for my test. Again, the computer output always does two-sided. Does that make sense to everyone? Yeah. So the computer output does two-sided. If you're not doing two-sided, keep that in mind. So what's going to happen on a free response question if you get 0.005? Probably miss a point. You'll get a 3 out of 4 in the question instead of a 4 out of 4. But that's a silly reason to not miss a point. So just keep that in mind. Yeah. So even though the computer output's doing something, you can always fiddle with it to get what you need. So let me make a conclusion. We should be really good at making conclusions at this point. So what should we say? The p-value is lower than alpha equal 0.05, right? Because that's what it tells us in the question, so we can directly reference it. We reject. So if we reject the null, again, looking at our hypotheses and what the question asks, what does that mean in context? Increase. Or you could say, you could also say there's evidence that as the number of study hours increases, your test scores increase as well. Does the hypothesis test make sense? That's all it is.